So, good morning, afternoon, or evening, whatever it is in your corner of the world. My name is Amelia Ortiz-Gil, and I work on outreach and education at the Astronomical Observatory of the University of Valencia in Spain. First of all, I would like to thank the organizers of the meeting, and in particular, Marcus and Gwen for inviting me to give this keynote lecture. Let me share my screen now. So today I'm going to talk about equity, diversity, and inclusion in astronomy education. In this first slide, you can see the pictures of 6 key scientists and engineers: Leonardo da Vinci, Isaac Newton, John Goodrich, Thomas Edison, Albert Einstein, and Stephen Hawking. So these guys were all male and white, and they also had another common feature, which was that they all had some kind of physical or learning disability. But in their case, and luckily for us, this was no obstacle to devote their lives to science. They were lucky to find the means and support that they needed to thrive in science. But how many others have not been that lucky? How many brilliant geniuses have been lost because they lacked the material means and the support necessary for them to learn and to work? So my point here is that we lose talent, a lot of talent, when we do not provide for inclusive measures to embrace the diversity of our students. And of course it is a moral duty, but I think you all agree with that. So my goal in this talk is to stress that besides being a moral duty, it is also a strategic measure for the advancement of science. Including the diverse ones may seem a bit daunting at the beginning, but it is really not that difficult in general. Sometimes it is just a matter of removing unnecessary barriers. So let me show you a very simple example of what I mean. We have here 2 versions of the same graph. The graph shows the evolution along the years in the number of users of 3 operating systems: Windows, Linux, and Macintosh. On the x-axis, we have years from 1990 to 2003, and on the y-axis, we have the percentage of users. The version of the graph, which is on the left, uses only color for distinguishing between the different lines corresponding to each of the 3 different operating systems. The choice of these particular colors is highly not colorblind friendly. The other graph on the right not only uses colorblind friendly colors, but also different kinds of lines, dotted, dashed, and continuous, to distinguish between the different operating systems. So I would like to stress here that it is not only more colorblind friendly, but it is also better for anyone who can see it. And there are many of these barriers in the learning materials, and many students can feel discouraged when encountering these obstacles. And it can be even worse if, besides the disability, they belong to some racial or cultural minority or underserved social group. So let's start with a bit of context. By diversity, I mean a variety of ethnic, gender, functional abilities, socioeconomic background, culture, religion, and so on. And on the other hand, inclusion is reached by creating a safe environment in which everybody can speak out and act freely without fear of embarrassment, where they feel valued and belonging, and where everybody is equally treated and treated with respect. And of course, in creating this safe environment, teachers and educators play a fundamental role, and it is therefore very important that they are committed to achieving real inclusion in their classroom. So it is also critical to embrace the differences, taking advantage of what diversity has to offer, and not to just ignore them and pretend that differences do not matter. Mhm. So as I have hinted at the beginning, diversity is key for the scientific success of research teams, whereas it is a research team in a classroom or in a professional lab. And why is that? Well, let's suppose we follow the inquiry-based learning methods in our classroom, and different team members can prefer different approaches to the task in hand, and they can come up with a wider diversity in the questions that are being asked. This in turn fosters creativity, success in problem solving and decision making, and all this contributes to the final scientific success. And this is so because interacting with people who are different from us in terms of functional abilities or culture, gender, ethnicity, and so on, forces us to prepare better our argumentations, to anticipate alternative points of view and how to respond to them, to expect that reaching a consensus will take effort. And it also helps us to overcome cultural biases and misunderstandings. In the end, all this will help the kids to be better prepared to create and put a high value in diverse and fair work environments when they grow up. So this is all very nice and obviously easier said than done. But again, it is not such an impossible task as it might seem. And I am sure that many of you have already put in place some inclusive actions in your classroom. So there are different methods that one can use, but I particularly like the universal design for learning because it seems to me quite intuitive and common sense based. UDL is defined as a framework based on strategies, technologies that support multiple learning modalities, including visual, auditory, kinesthetic, and tactile, which are the traditional ones. And if you take your activities, materials, and resources and apply the UDL principles to adapt them, or even better, if you develop your lessons according to the UDL principles, you will end up with a set of materials that will be accessible and even more effective for everybody, regardless of any particular disabilities anyone might have. And to do this according to the UDL, you have to identify and remove any kind of barriers, which could be physical, sensorial, affective, or cognitive, to gain access, learning, and participation for students and for everybody in general. The key then is not to focus on the disabled person, trying to change them, but on the disabling environment. And we all have experienced this. If there was a lot of noise in this room, you would not hear me and you'd be sort of deaf. I could give you all a hearing aid device, or better, I can remove the source of the noise. So the key here is multiplicity. Provide multiple means of representation, provide multiple means for taking action and communicating, and provide multiple means for engagement. We need to provide multiple means of representation. As different people perceive information in a different way, we must provide the contents through different perception channels. Beethoven could not hear the music, but he could read the sheet music and feel the vibrations of the sounds which were being played. We have to provide multiple means for taking action and communicating, because the students differ in the ways in which they interact with the learning environment and communicate their thoughts. So we have to give them opportunities for taking action through materials everyone can interact with, and opportunities for communication by the use of software and other means. And a good example of this is Professor Stephen Hawking. He had a brilliant mind inside a body which could hardly move, and he was able to work and to tell us about his discoveries thanks to the technical means that he was using. Also, students differ in the ways in which they can feel engaged and motivated to learn. So use wide choices that reflect the interests of the kids. For example, whether it is sport or technological gadgets, art, social media. And it is also important to provide them with strategies to deal with new contents. An example for a general protocol to follow would be this: teach through all senses, teach to strengths, and provide multiple forms of feedback. So it has been shown that learning process is more effective when contents are provided through different sensorial channels. It is easier to remember something that you have read about, touched, heard, and smelled than something that you have just heard. Teach to strengths, that is, you have to use the natural abilities and talents as a foundation for the learning process. Or in other words, focus on the abilities of the student rather than on the disabilities. Everybody has talents, so we have to identify them and use them. Finally, to gather a complete picture of the abilities of your students and to check whether the contents are being received correctly, you need to use multiple forms of feedback, which could be written essays for some students or oral presentations for others, for example. Some examples of specific actions that you can carry out. Well, first of all, you have to check with the students about their special learning needs, and then make sure that activities, materials, and equipment are physically accessible to and usable by all, involving as many senses as possible, and also taking into account possible learning disabilities. You also have to use a variety of means to deliver content, motivate and engage the participants. You can use hands-on activities or collaborative learning, educational software, inquiry-based learning, internet-based communications. You have to make sure that the communication methods are accessible to all students. And in these group activities, students have to support one another by placing a high value on their different skills and capacities. And this also helps them to build up their own self-esteem. It's crucial that you ask for regular feedback from the students, so you learn whether there is the need of adjusting the activities, and for that, plan for alternative accommodations for students whose learning needs are not met by the activity. For example, it can help to get materials under different formats. So I will now describe briefly some of our attempts to organize accessible outreach activities at the Astronomical Observatory, where I work at the University of Valencia in Spain. We have been carrying school activities at the observatory since 2003. And in 2006, we got a request from a special education school. And then we decided to develop a new kind of visit, which was tailored to their needs. It was the very first time we were doing something of this sort. So we were fully aware of our ignorance, and we worked really, really close with our teachers to design the visit. We developed 2 PowerPoint presentations to begin with, and one of the presentations was about images of planets and moons that were reinforced by other sensorial stimuli. For example, when we were talking about frozen surface of Jupiter's moon, Europa, we were handing to them some balloons filled with cold water. Or when we were talking about Mars, they were giving some sand to put their hands in. After that, we also had some very relaxing presentation with nice images and quiet music. We also had some hands-on activities. We built a cardboard sundial constellations with glow-in-the-dark stars. We launched water rockets, and we had a planetarium session in our inflatable planetarium. During the International Year of Astronomy in 2009, we also developed new resources. First, we created an open source software called AstroAdapt for people with motor disabilities. It's software that you install on the computer attached to the chair of the user, and they can use this software to communicate with their carers and also to explore some astronomical contents. We also collaborated with the Astronomical Observatory of Padova in Italy. They had published in 2000 an online astronomy book for the blind. We translated it into Spanish and we printed it out in order to distribute it in different libraries belonging to visually impaired person associations. We also created a planetarium show for the visually impaired based on a previous experience in Argentina by Sebastian Musso. It had two main components. One was a tactile hemisphere in which the users could touch the shape of the constellations. And then there was a soundtrack with special sound effects that were heard coming from the dome of the planetarium, close to the place where the constellation image was being projected. So they could, the blind and visually impaired persons could hear where the particular constellation was being projected onto the dome. Then we designed a 3D tactile model of a moon for the blind, because so far all the models that we were aware of were flat. And in fact, during an activity with the 3D model of the moon, a blind lady discovered with surprise that the moon was a globe and not a disk. She had been convinced for her whole life that the moon was a disk hanging on the sky. So our goal here was to convey in a tactile way the image of the moon when we look at it from Earth, and to involve the blind in the same experience that other people have when looking at it. So we avoided mere topographical representation and enhanced the more peculiar and characteristic features that we can see on the moon surface. We produced a model that a blind person can explore completely autonomously without the help of other users. And we realized that we had gathered a few materials already for making astronomy inclusive or accessible astronomical lessons. So we put them all together with some other resources from other people, and we created a kit of accessible astronomy resources. There we included, of course, the planetarium show materials, the tactile moon, 3D models of constellations, a tactile from Earth to the Universe prints that were kindly provided by CFA, and the Little Moon Phase book by Stromir Norin Grice. And we also created an activity book to be used with activities related to the materials that were in the kit. Of course, the soundtrack of and the guide to implementing the planetarium show are also in the kit. For this, we got funding from the IAU Office of Astronomy for Development and the support from many other institutions. We produced 30 kits that we sent around the world, mainly to underdeveloped countries. And here you can see some girls in different schools with the materials in Nepal, Argentina, and India. So we decided that we wanted to more, and we started to develop tactile models of other planets. And we started with Mars, Mercury, and Venus. A friend of us, Jordi Burguet, developed a software that creates 3D tactile models directly from two-dimensional maps. So now if you want to create your own tactile globe, you can do that easily downloading this software, which is called Mapilia and Friends, and it's available also at the webpage of our project, Attach of the Universe. The planets were featured at the IAU traveling exhibition called Inspiring Stars. It is an exhibition to inspire younger generations. It's composed of accessible astronomy resources from all over the world. You can see here the tactile model of the Subaru telescope from the NAOJ, or another models by Thomas Madura. So I just wanted now to tell you about our working group on astronomy for equity and inclusion at the IAU, because this is an IAU symposium. So I thought I should just talk a little bit about this. We are now more than 200 members between astronomers, experts in accessibility, and outreach professionals and educators. We have divided the group into different working groups according to different topics, because some of them are really very, very different. One of the things we have, one of our products of the working group has been the Sign Language Universal Encyclopedic Dictionary. And we made the first release with 47 terms, astronomical terms, in 31 different sign languages. And the goal here is to develop a comparative list of astronomical terms. We also organized a couple of meetings on inclusive astronomy. And so to conclude, teaching using inclusive and accessible methods leads to the inclusion of students with disabilities, as well as making the learning process easier and more engaging for everyone. It helps in keeping and developing the talents that may hide behind a disability, and this will eventually foster scientific excellence in research institutions, and also to contribute to build more diverse, inclusive, and fair working environments for all in astronomy and in science. I leave you here with some links to the Attach of the Universe, which is the project where you can download all the tactile models of the planets that we have developed so far. You can find there also the software to make your own 3D models from maps. The link to the IAU working group on astronomy for equity and inclusion. You are welcome to become a member. Just write to me. Okay, the link to Inspiring Stars exhibitions, and a link to Spaces for Everyone, which is a document by NASA explaining quite very well, actually, the UDL framework applied to space science. So please feel free to contact me. Thank you very much for your attention.